Okay, ladies and gentlemen, we're on question number 5 from Supplement C. Let me read it to you, and then I'm going to look at the pertinent data I have already had kind of sketched down on my paper here for you. It has been observed that the average number of sodas N served at a football game increases linearly as the temperature T increases. So, T is temperature, N is the number of sodas. Okay? That's what they've told us. They've also told us this. The minute they said linear, they told us that y equals mx plus b is somehow going on here. Now, they give us data. At 80 degrees, fans consume half of a soda, half of a can of soda. At 88 degrees, fans consume 1.5 sodas. Now, obviously, you can assume the slope of this is positive because what's happening here is it said specifically it increases linearly as the temperature increases. Well, that makes sense. 102 degrees, we're probably getting real thirsty. Okay? Now, here's a very important thing to know. In this particular problem, Part A says express the number of sodas N as a function of T. Express N as a function of T. This is what this means. N is a function of T. And we know this is MT plus B. Y equals MX plus B. Here it becomes N of T equals M times T plus B. M is still M, B is B, but the input is no longer called X, it's called T. Something I want you to notice. T is the temperature, N is the number of sodas. I call this my legend when I'm doing these problems. Input is temperature, output is, in this case, number of sodas. Always make sure you're putting your ordered pairs in that way. So here, at 80 degrees, they consume 0.5 sodas. So that would be the ordered pair 80, 0.5. At 88 degrees, they consume 1.5 sodas. So at 88 degrees, 1.5. So temperature comes first, number of sodas comes second. Temperature, number of sodas. Now the sad part here is none of these are B. We're going to have to do some work to get B. The only way we would have B is if one of these was 0, and they unfortunately didn't give us that. All right? So, first thing I have to find is M. Slope is usually called change in Y over change in X, but in this case, Y, the output is N. So slope is change in N over change in T. Okay? Change in output divided by change in input. To find change, we always subtract. The top numbers are my change in N. Okay? N here is 1.5. And here it's 0.5. And temperature, we started here, so we're going to start here for temperature. 88 and 80. So we end up with what on the top? 1, and on the bottom, an 8. Okay? Now, 1 over 8 is a perfectly correct way to leave your answer, but personally, let's see what that comes out to. If I typed on my calculator, let me type 1 divided by 8. And I'm actually going to come out with, it comes out nicely. It's not even a repeating, it terminates, right? It's 0.125. So I'm personally going to use the decimal form because it's clean. If it was something like 0.3333 repeating, I wouldn't want that. I'd leave it as a fraction. Okay, but I'm going to use 0.125. So, here we go. N of T, we wrote originally was MT plus B. Well, we just found out that the slope is 0.125, so we know we can put that in. And now we need to find B. The way we're going to find B is we're going to take one of our ordered pairs and plug it in. It doesn't matter which one we take. I'll take, I think there was one that said, one of our ordered pairs said, what was it, 88? Yeah, there it is. 88, 1.5. So what that means is, okay, this is T and this is N. So if this becomes 1.5, that's what N is, that means we put in 88. So I have this equation. 1.5 output equals 0.125 times the input of 88 plus B. Let me go to my calculator. 0.125 times 88 is equal to, all right, this is equal to 11. This was 11. And then I'm going to subtract 11 from both sides. And make sure. Don't want to screw up signs. That's, you want to be very careful with the signs and with the number. And I've got a calculator sitting here. And I'm making a video, so I don't want to embarrass myself royally. So negative 9.5 is going to be what I have for B. So my answer to part A, N of T is equal to 0.125 T minus 9.5. This is my function that measures the number of sodas based on temperature, the number of sodas that will be consumed based on temperature. You saw how I found M, and then you saw how I found B. Okay? Now, part B is usually the easy part. Part B says, how many sodas will be consumed on an average if the temperature is 90? Okay. So we're finding N of, and for temperature we're putting in 90. So we take 0.125 times 90 minus 9.5. Okay, let me go over to my calculator. 0.125 times 90, and then minus 9.5, and I'm getting the answer 1.75. So at 90 degrees, about 1 3/4 cans of soda on the average will be consumed. And we're done.